The following program is brought to you by the Center for Educational Outreach at Baylor College of Medicine.
The first of a series of workshops on life science topics that are related to long-duration space flight. At Baylor, we've been involved, in addition to the research, in developing educational outreach materials. And we will be going through one of the units that we've developed with funding from NSBRI to help students understand, first, a lot of basic science, some of which you've already had an introduction to. But at the same time, to help them understand, to place that in the context of long-term space travel. Because we also have found that students love to learn about space. The whole connection to science fiction and astronauts and all of that is usually pretty compelling to kids. So the unit that we're looking at today, as you probably already guessed, is food and fitness. So we're going to go through some of the basic concepts related to food and fitness, starting with energy. And how do we measure energy? And why do living things need energy? Then we're all going to calculate how much energy we as individuals need. So we'll calculate how many calories each of us is burning when we're resting, when we're exercising. And then we'll work on some activities looking at helping kids make better food choices. So we'll be working through hands-on activities that really relate to the concepts in the presentation you just heard. So we're going to start. Let's just think about living things and energies for a moment. What do all living things need? What would your students say all living things need? Water? Air? Food? Shelter? Sunlight if we're certain kinds of organisms, right? Because students, by the time they get to you in middle school, will know about producers and consumers, right? Mm-hmm. Producers who can make their own food through photosynthesis, and consumers who exactly are the ones who need to eat something else to get their energy source. We're going to take a look at one of my favorite model organisms that kids may not even think of something of being alive. How many of you think that students will think of yeast as being a living organism? No. Yeah, it's something that we use to bake bread. But it's important to keep in mind that yeast are a member of the fungus kingdom. They're related to mushrooms. They're related to the mildew that tends to grow on the walls here in Houston in damp places. They are a living organism. So the question that we're going to ask students is, what do you think will happen when yeast is combined with water and when yeast is combined with sugar and water? So let's just take a moment and we'll work in two groups. And within each group, and of course this isn't going to take you very long, to make a prediction, especially if you do any bread baking, what will happen if you combine yeast and water, and what will happen if you combine yeast, water, and sugar? Well, we're going to have an opportunity to investigate this. What each group will do, you have a beaker of water on your table. You're going to measure 50 milliliters. It's about room temperature water. You're going to measure about 50 milliliters of water into each cup. You're going to add a package of yeast to each cup. And then you're only going to add sugar to one of the treatments. So be sure to mark them with a Sharpie, which one is going to have food and which one is not going to have food. And then we're going to watch it over time. So I'll give you a few moments to set it up. You have the instructions in front of you in case you have any questions.
One packet of sugar is a teaspoon, so you need 2 packets.
Yeah, so record your starting temperature.
Then that's fine.
And what you'll be measuring is the height of the mixture in each of the cups. Now, if the yeast is a living organism, what might we expect to happen if we're feeding the yeast? Because that's what we've done, right? We've just given the yeast a food source. So we would expect the yeast to grow and reproduce, right? Use a lab probe, and we'll set up a culture later this morning with a probe so we can make a graph. what would we expect to happen if the yeast are using food for energy? It would grow and reproduce, but what would happen to the temperature of the water?
Right. It would increase.
It would increase, right? Because one of the things that happens when we use energy is that heat is released. In fact, a nice way to even demonstrate this to your students is you've all done the rub your hands together. Everyone rub their hands together. It's cold in here anyway. Rub your hands together. We're using what when we do this? We're using energy. And what is happening to the temperature of your hands? It's getting warm. And of course, we use this to understand friction, but also anytime there's movement and there's use of energy, heat is released.
The water is still
The same. Yes. No change.
There's something wrong with this stage.
Could you put the two next to each other?
Okay.
You see anything?
Well, let's see. I'm trying to get it to. Yeah, I mean it's great. How many observation points do we have? Do we have 4 yet?
Yes.
4? Okay. Because what we can do is we can graph our data then. We can do a group graph. Okay, first group, what were your measurements? And we'll do 2 separate lines on here.
2.1.
2.1.
2.1. It could have been 2 centimeters.
Okay, it started at 2.1. Okay.
5 minutes later.
Okay, so these are 5-minute intervals, right? So that's times 0. Okay, here's 5.
2.5.
2.5. Okay.
You got this, okay? Yeah.
Okay, and at 10 minutes?
3.5.
Wow.
Did you get about the same?
3.5. Oh, isn't that nice? Okay, and at 15 minutes?
5.
Ah! Okay, there's 4. It's a good thing I made this 5. Oh, look at that. That is just a... Oops.
That's what you expected. Somewhere there. Yes.
Oh, isn't that nice? Okay, let's go with the other group. What was your initial measurement?
2.4.
2.4. Okay, we'll make your group circles. Okay.
Then 3,
3,
4,
4,
and 5.1.
5.1. So yours is a little above. The really interesting thing is it demonstrates this is not, it's not a straight line, is it? It's a curve.
That's what you want to see.
It's a curve. It's a growth curve because of the way that the yeast are reproducing, right? First we have 1 yeast cell, it becomes 2, they split, 4, 8, right? So if we would continue to draw this, we would expect that we would get this very nice exponential growth curve. But we're measuring it not by counting yeast cells, right? We're measuring it by measuring the height of the foam, which is fun. So that's our graph. Let's look at the other questions related to this. Okay. Then you would want your students on a separate sheet of paper to write a paragraph describing their observations, right? Because hopefully they would have been making observations in addition to the height. What is the final temperatures of your mixtures? And what was your initial temperature reading?
20.
20 from 20 to? From 20 to 23, so you had a 3-degree increase in the temperature.
28, Did you wash it with cold water?
So again, this provides more evidence that something was happening with the food source and the yeast, right? So we've got 2 really, well, we have some yeast cells under the microscope, but we also have 2 measures that the yeast was using food, right? The first measure is what?
The growth?
The growth and the height of the foam, right? And what, of course, is the gas that's producing all those bubbles? Carbon dioxide, right? Which is always produced as a byproduct of using food or of burning, right? Okay, and so then the other measure, so we've got the height of the foam and we've got the change in temperature. So the final question then for your students is, what was the role of sugar in this activity? It was the food. It was the source of energy for the yeast. Yeah. So we've had a little bit of an introduction now to what happens when organisms use food. They grow, reproduce, they release carbon dioxide. Heat is also released when we use food.